Think of the Pacific Ocean like a giant bathtub. Under normal conditions, steady trade winds blow from east to west. They push warm surface water toward Australia and Southeast Asia. As that warm water moves away from South America, cold water rises from deep below to replace it. That cold water matters more than most people realize. It carries nutrients to the surface. Those nutrients feed tiny marine life, which feed the fish. It is one of the main reasons the waters off Peru are usually so productive. Then the trade winds begin to weaken. The warm water that had been piled up in the western Pacific starts sliding back toward the east. It spreads across thousands of miles of ocean and settles near the coast of South America. Now the cold water can't rise the way it normally does. The flow of nutrients slows down. Sometimes it nearly stops. The fish lose their food. Many move deeper. Others leave the area completely. Fishing crews come back with smaller catches, and places like Lima suddenly get clearer skies and much warmer days. But this is where the story gets much bigger than fishing. Warm ocean water puts more moisture into the air. That warm, wet air rises and creates powerful thunderstorms. Not just one storm, but huge zones of storm activity stretching across the Pacific. Those rising columns of air help shape the jet stream, the fast-moving winds high above us that guide storms across entire continents. So the warm water isn't directly sending a storm to California, Texas, India, or Africa. It is moving the place where the atmosphere rises and releases heat. Once that center shifts, the winds around it shift too. Storm tracks move. Rainfall changes. Some regions get flooded while others wait weeks for rain that never comes. That is the real power of El Niño. It begins as warm water in one part of the Pacific, but it can end by changing the weather thousands of miles away. When scientists watch El Niño, they don't just stare at a thermometer. They watch one small part of the Central Pacific the way a doctor watches a heart monitor. They're looking for signs that the whole system is starting to change. Right now, that area is about 1.2 degrees Celsius warmer than normal, and it's still getting warmer. At first, that number doesn't sound like a big deal, just over 1 degree. But the Pacific isn't a swimming pool. It's one of the largest bodies of water on Earth. Raising the temperature of an ocean that size by even 1 degree takes an unbelievable amount of energy. But here's what really got scientists' attention. It wasn't the water, it was the sky. Thunderstorms started building over the central and eastern Pacific more often than usual. At the same time, storm activity around Indonesia began to fade. That means the rising column of warm, moist air had actually shifted across the ocean. And that's a huge deal, because once the atmosphere starts moving with the ocean, El Niño is no longer just a forecast sitting on a computer screen. It's happening in real time. This is the moment scientists wait for. Warm water by itself doesn't always change weather around the world. The ocean can heat up for a while without causing major global impacts. But when the atmosphere responds and begins moving with it, that's when the chain reaction really begins. The winds change. Storm tracks start shifting. Rain falls in different places. Dry regions get even drier, while others suddenly deal with flooding. That's why researchers pay just as much attention to the atmosphere as they do to the ocean. When both are working together, El Niño stops being a possibility. It becomes a system that's already reshaping weather across the planet. One of the first places El Niño leaves its mark is Peru. At first, it looks like a local fishing problem, but it's much bigger than that. Peru has one of the largest anchovy fisheries in the world. Most people have never seen these fish, and many don't even know they exist, but they play a huge role in the global food chain. They're turned into fish meal that's used to feed farmed salmon, chickens, pigs, and many other animals. So even if you've never been anywhere near Peru, there's a good chance you've benefited from this fishery without realizing it. The problem starts when the cold, nutrient-rich water stops rising from the deep ocean. Without those nutrients, the tiny organisms that anchovies feed on begin to disappear. The fish suddenly lose their food source. Some swim much deeper, where colder water still exists. Others leave the area altogether. That didn't take long to show up in the fishing industry. Peru lowered its fishing quota to the smallest level seen in about 10 years. Even then, fishing boats were catching far less than expected. What worried experts even more was that more than half of the fish being caught were juveniles. They hadn't even had a chance to reproduce yet. That's when Peru made a difficult decision. The fishing season was shut down early to protect the remaining population before even more damage could be done. And that's the lesson people often miss. The biggest loss isn't just this year's catch. It's what happens next year if too many young fish are removed before they can reproduce. A single change in ocean temperature off the coast of Peru can eventually ripple through global food supplies, affect livestock feed, and push food prices higher in countries thousands of miles away. That's how connected this system really is. One of the biggest myths about El Niño is that it simply shuts the rain off. That's not usually what happens. In India, it's often much more complicated than that. El Niño weakens the winds that normally carry moisture from the ocean onto the land. Early in the season, that showed up fast. Rainfall dropped to about 41% below normal, and many people feared a serious drought was already taking shape. Then everything changed. Within just a few days, powerful storm systems rolled in. Heavy rain returned almost all at once. The rainfall deficit shrank quickly, but it came with a different set of problems. Floods spread across parts of the country. Landslides followed. Emergency alerts were issued in several regions. This is what makes El Niño so difficult to deal with. It doesn't always take the rain away. It changes the timing. You can go through weeks of dry weather, wondering if the rain will ever come. Then suddenly, too much falls in just a few days. After that, the dry conditions return again. For farmers, that's often worse than a steady drought. Crops don't just need water. They need it at the right time. A month's worth of rain falling in 1 week can't make up for weeks of dry soil. In many cases, it floods the fields first, then leaves the ground baking under the sun once the storms move on. That's why seasonal rainfall totals don't always tell the real story. The bigger risk isn't simply getting less rain. It's losing the rhythm that farmers have depended on for generations. When the seasons stop behaving the way people expect, planning becomes almost impossible, and that's where El Niño can do some of its greatest damage. When people hear about record-breaking heat, it's easy to blame El Niño, but that's not always the right answer. Take Europe, for example. Many parts of Europe recently experienced extreme heat. Temperatures broke records, and thousands of people were affected. At first, it seemed obvious that El Niño had to be behind it, but when scientists looked closer, they found something different. Their climate models showed that El Niño wasn't the main cause of that heat wave. The biggest reason was a long-lasting high-pressure system, often called a heat dome. It trapped hot air over the region for days, allowing temperatures to keep climbing. There's another reason, too. Europe today is already much warmer than it was a few decades ago. That higher baseline means heat waves can become more intense, even without El Niño playing a major role. Timing matters as well. When this event was officially declared, El Niño was still in its early stages. During the Northern Hemisphere summer, its influence hadn't fully spread across the globe yet. Historically, its strongest effects tend to show up later, especially during the fall, the winter, and even into the following year. That's an important distinction. Climate change and El Niño are connected, but they're not the same thing. Climate change raises the starting temperature of the planet. El Niño releases stored heat from the Pacific and reshapes weather patterns around the world. When those two happen at the same time, the impacts can become much more noticeable. So it's not accurate to say El Niño creates every heat wave, but when it develops on a planet that's already running hotter than normal, it can push weather into places we've never seen before. Here's something that surprises a lot of people. A strong El Niño can actually make the Atlantic hurricane season quieter. At first, that sounds like good news. Fewer hurricanes should mean less danger, right? Not exactly. When El Niño gets stronger, it changes the winds high above the Atlantic and the Caribbean. Those upper-level winds become more unstable, creating what's known as wind shear. Think of wind shear like someone trying to build a tower, while another person keeps pushing it from the side. A hurricane needs calm, steady conditions to grow, but strong wind shear tilts the storm, pulls it apart, and often stops it from becoming a major hurricane. That's why the Atlantic usually sees fewer powerful storms during a strong El Niño. But here's the part many people miss. The danger doesn't disappear, it moves. While the Atlantic becomes less favorable for hurricanes, the Eastern Pacific often becomes much more favorable. The ocean there gets warmer, wind shear weakens, and storms have a much easier time forming and strengthening. That puts places like Mexico and parts of Central America at greater risk. So the question isn't whether El Niño makes the world safer. It doesn't. It simply changes where the greatest risks are. One coastline may have a quieter season than usual, while another prepares for stronger storms than expected. That's why meteorologists never look at just one ocean. The atmosphere connects them all. What calms one region can increase the danger somewhere else. And that's exactly what makes El Niño such a global event. It doesn't remove the threat. It redistributes it across the planet. One of the biggest mistakes people make is thinking El Niño affects the whole world the same way. It doesn't. Every region gets its own version of the story. In North America, the southern United States often has a wetter and cooler winter. For places dealing with drought, that extra rain can be a relief, but if too much falls too quickly, flooding becomes the next problem. The northern U.S., including the Pacific Northwest and the Rocky Mountains, usually sees the opposite. Winters tend to be warmer and drier. Less snow in the mountains might not sound like a big deal, but that snow acts like a natural reservoir. It melts slowly through the summer and supplies water for millions of people. When there's less snow, rivers shrink sooner, and wildfire season can last even longer. Western Canada often follows a similar pattern. Warmer, drier conditions increase the risk of drought and large wildfires, especially across the prairie provinces in British Columbia. Over in East Africa, countries like Kenya, Somalia, and Ethiopia often receive more rain during El Niño. But more rain doesn't always mean better conditions. Heavy downpours can trigger severe flooding, destroy homes, damage crops, and force hundreds of thousands of people to leave everything behind. South America is split as well. The Amazon basin often becomes hotter and drier, raising the risk of major wildfires. Meanwhile, countries farther south, including Argentina, Uruguay, and southern Brazil, usually experience above-average rainfall and a greater chance of flooding. Then there's Australia, where the signal is one of the clearest in the world. As warm water moves away from Australia, so does much of its rainfall. Spring and summer often turn hotter and drier. Water supplies shrink, farmers face growing pressure, and bushfire season becomes longer, more intense, and far more dangerous. That's what makes El Niño so remarkable. It isn't one disaster happening everywhere. It's the same climate event, creating completely different challenges, depending on where you live. One thing about El Niño is easy to misunderstand. It doesn't create brand new heat out of nowhere. Instead, it releases heat that the Pacific Ocean has been storing for years and sends it back into the atmosphere. That's how this cycle has always worked. The difference this time is where we're starting from. Past major El Niño events happened on a cooler planet. Today, the Earth is already warmer than it has ever been in modern history. So when El Niño adds even more heat to the system, the effects can become much more noticeable. The good news is that this isn't the kind of disaster that appears overnight. El Niño develops over months. Scientists track it every week. Governments, farmers, fishing industries, and local communities all have time to prepare before the strongest impacts arrive. That doesn't mean every forecast will be perfect. Weather never works that way. But having months of warning is far better than having none at all. In the end, we can't stop the Pacific Ocean from changing. What we can do is pay attention, understand what's happening, and use the time we have to get ready. Because sometimes, the biggest difference isn't whether a disaster happens. It's whether we saw it coming and chose to prepare before it reached us.